黑巧主要是黑巧哦，好的，你要减肥都早上吃黑巧，我是为了甜，不是为了让
我也会吃，别人给我吃的巧克力，就苦的发酸，真的特别苦。
那家黑巧，
太可怕了。
你知道瑞士人80%的黑巧苦到发酸，就是那种感觉。
吃巧克力，
就是为了开心吗？降低心很可惜。
他们没是骗我。这个，
我觉得我这个也好吃。我不知道它。
I'll take 10 minutes break and then
我
I'll
每
play
次吃的
that.
都是就是巧克力。
Okay, guys.
是那种太妃糖。
Hello, you done it?
Yeah,
Good man, good. Great.
thank you.
Everything okay? How's your courses going? Okay?
Yeah, but
Anything difficult?
Martingales is the hardest one.
Oh,
Martingales and Matrix are the hardest ones. But
good. Who's teaching Martingales?
pardon?
Who's teaching those courses?
I don't even know the guy's name. No idea. That's all.
Okay.
But SAS Experience, it's alright. But I've not started like revising it.
Okay.
Yeah, I just need to catch up on that. Then I'll be fine. Yeah.
Take care, man. Alright guys, when you have time, can you get started on this? I will take a break. I will take a break for 10 minutes and come back. But in the meantime, you can start on this.
330毫升能用很久。我那瓶紫苏水用了好久都没有用完过，而且我用它湿敷，用了好久。而且我找代购买了那瓶紫苏水才300毫升才300多一点。
用的很慢，你那瓶看是原来的300毫升，用了很多月了，我400毫升的用的是用了大概2年了。
不管用水就应该用来湿敷。
对啊，就这么湿。
所以就是后来粉水我用不下去，因为没有办法用来湿敷。
不舍得用它湿敷。
不是它粘稠。
太黏了，粉水嘛。
对，它很粘稠，它适合干皮。油比较黏，我是实在是受不了，它真的太好看了，而且味道又很好闻，我买了。我后来就把它放那个喷雾，你知道吗？就那个装电池水桶啊，喷出来那个，我就放在那里。
会喷出来吗？
每次出来吗？没有加水的。
因为加兑水。
当然要兑水，它手工兑水。那对，不然它喷不出来。
而且主要是还有几天拿那么多。
就多到就都很容易多。我后来把它分装到小瓶子里面，再就是从小瓶子里倒。
哇，你好聪明！你有发现什么吗？
粉水，我说它太大瓶不好倒，我就装到小瓶里，然后再从小瓶往外倒。
可是这样你就享受不了从这个好看的苹果里。
好看你就摆着看嘛。从好看的瓶子里倒一手，你开心吗？
这特别大，然后又。
还有人会把上面那个透明的盖子给拧开，像我书上说的，反着拧开，然后上面还有个小瓶。但我觉得不应该是那样倒的，我觉得不应该，怪怪的。
我觉得兰蔻家的产品都很不懂。
那个紫色也很好，其实是我最喜欢的色，适合。好像是抗皱什么的，因为我这个年纪很虚。你那个时候不服老。 然后30几岁的时候是后悔。
高你话说的好骄傲啊！
不需要，没有到那个年纪。可以让他老师帮我请最后面，我看这个。
这个球打开，这个帮我。
Alright guys, can you do question 1 please? Question 1. Yes, okay. Do you have an afternoon sheet? Somebody has the afternoon sheet?
Yeah.
Okay. Why do you have the limits from 0 to 1? Why is it from 0 to 1? Okay. Okay, it looks correct. I mean, the approach, yeah, you understand.
This is not showing the answer, but
Okay, maybe there is a mistake in the answer. I don't know. I think your approach is correct. Your approach is correct. Yeah.
I'm confused
Yeah. Well, when it's 0, it becomes an exponential distribution. You have to use the, remember what I said to you in the class, in the lectures. When it's 0, you have to use the fact that it is a limit. It's a limit as opposed to 0, which is that the question number 2, it will become exponential. Can I write down? Sorry. For question number 2, which one are you doing? Number 2, right?
Yeah.
Is it the second question you're doing? Or the first one? Second one. That when psi is 0, this will become 1 minus e of minus x. This is what you will get when psi is 0.
Okay.
Yeah, that's what you will get. Alright guys, let me show you how to do it. I mean, these questions are not really difficult. You shouldn't find it, given what I did in the class, guys, you shouldn't find it difficult, guys. So let's start with question 1. Question 1, okay? The part A is to find the PDF. The PDF is just simply the derivative of the CDF, right? So what do you get? You should differentiate this. You will get what? Just a minute. I'm trying to pick. You will get the following. I think 1 plus. Correct me if I'm wrong. This is what you will get. Is that right? Is this what you got, guys, or no? Yes or no? Okay. So for part B is to find the nth moment, so which is the expectation of, when I say n, it means we want to find the expectation of x to the power n, which is the integral from yes, so this is integral of x to the n dx. Okay. Right, and in this case, I think one way, I mean, there are many ways you can do this question. One way is to consider the 3 cases separately. You remember the cases where psi is positive, psi is equal to 0, and psi is negative, right? That can be a long way to do it. Another way to do this problem is just to, we know that this guy here must be between 0 and infinity, right? So another way to do this is as follows, is to make the substitution. So I'm gonna, let me use the red pen, set I'm going to make this substitution, right? So this implies that right, and this implies that dx by dy is minus y. Okay, so let me put this in a box. So that the reason I'm doing, and the reason for this will become clear in a minute. Why I'm doing this, I will explain in a minute why I'm doing this. I made this substitution and then computed x in terms of y, which I think this is correct, and then I computed dx by dy, which is this, I think. Yeah. Okay. Now, if you make, should go back to the integral, you will see that x in place of x you have this guy here, right? And in place of this guy here, you have y then 1 plus side, and then you have e of minus y, and then you have minus y dy. Okay, you see what I've done. I've substituted all the x's by I substituted all the x's by y's. Alright, so you see that this guy here cancels out with this term here, so you get, what you get is the following. You get minus outside, and minus outside, and then inside you have this term, right? The one thing I forgot to do is to not to give the limits, but you can see, if you look carefully, you will see that the limit of integration must be from infinity to 0 here. Do you see why? Because the limits of integration must be from infinity to 0, because this term, you should look at this term here, right, which we are substituting for, right? When x is minus infinity, when x goes to minus infinity, this term must be plus infinity, right? Because if this term is plus infinity, exponential of minus infinity becomes 0. right? And when x goes to plus infinity, this term must be 0, right? Because exponential of 0 is 1. And as you know, as x goes to plus infinity, this must go to 1. So the limits of integration, well, I have explained to you, I haven't put them, must be from infinity to 0. Doesn't matter what size, it doesn't matter what the value for the parameter psi is. The limits must be from infinity to 0. Do you guys follow me or not? Just think about it. I mean, you don't have to do it this way, but this is one way of doing it. I will explain that later if you need more details. So what I have done, this becomes equal to, now you should use the minus sign. It will go back to 0 to infinity of like this, and this will be 1 over psi. And now you should use the binomial expansion. So there's an n here missing. You should use the binomial expansion, guys. Alright, and this will become alright, so this is the answer for part B. For part C, all you have to put is n equal to 1. Right, for part D, you just put n equal to 1 and 2. That's it. So that's completes question 1. But the difficult part here is to actually get the nth moment. I don't know whether you understood. I don't know whether you really understood what I did. But if you did not, I will explain again. I will explain again why I did it this way. The reason I did it like this is because this, when you do it like this, you can forget about the sign of psi. It doesn't matter what sign, whether it's positive or negative or 0. This method applies to any value for psi, right? And I chose this substitution because I know that this guy here is what is inside the CDF. This term here, right? This term is what is inside the CDF. So therefore, because you have fx equal to e of, right? This is the CDF, right? Okay. So this term is basically the power of the exponential term for the CDF, right? And therefore, the range of this must be always from, this must belong to the interval from 0 to infinity. Right? You understand? Do you understand why? Because it's the power of the exponential for the CDF, the range of values for the power must be from 0 to infinity. Yeah? So that's precisely why I made that substitution, because I can use the fact that the range or the domain of values for that term, right, that I chose to substitute, are always between 0 and infinity. Right? Okay? Is that clear, guys, or not? Come on, guys. If you have questions, ask me. Feel free. I can give you more chocolates if you want. Oh, you said, is that okay with you? Yeah, yeah, that's. So you understand why? I chose this substitution? It's because this guy here is exactly the power of the E term in the CDF, and therefore this must take values between 0 and infinity. Being the power, it must always be between 0 and infinity for any distribution function. Yeah. Can you do question 2, please? Question 2. And try to do it in the same way. If you understood question 1, you should be able to do question 2 by yourself without my help. You okay? You have questions? Yes. You mean the way I did it? No. No, that's because like here, when x is in the load minus infinity, this must be plus infinity. Otherwise it cannot be. Remember, the CDF must be 0 when it starts with. See, the CDF, when x is minus infinity, the CDF must be 0. So for this to be 0, this must be plus infinity. So the limits of integration are from infinity to 0. Must always be from infinity to 0, not the other way around. Okay. Yeah. You have questions? Sir. That's because of this minus sign here. There's a minus sign here, you see. Dx by dy has a minus sign. That's why you got this minus sign. Yeah. Yes. Yeah, I did it in a different way. Yeah. This is a different way. This is not the same as the solution. Yeah, it's not the solution. It's not. I did it in a different way. Yeah. How are you, man? You okay? Hello? You have questions? How are you guys? You alright?
Yeah.
How are you, man? You okay?
Yeah.
You okay? You look forward to it, right? How are you? Yeah, you're okay. How are you? Alright. Hey, don't worry about the fight. Just use the same approach I did here. Don't worry about the range. No, it's similar to this. It's similar to question 1, but the thing is the same. It's really similar to this. So you don't need to worry about the range. Just think about it. Think about it. You don't need to worry about the domain. You need to worry about the domain of y, not the domain of x. So you need to substitute for y. You understand? You need to find the substitution, the correct substitution. And then look for the domain for y, not domain of x. Right? I mean, you should really understand this question, guys. You should be able to do question 2 easily without. You guys okay? It's not binomial, it's a binomial series. Binomial expansion. This is a binomial expansion of this one. Can you see that? No? Can I use your pen method? Can I write it? Yeah, it's like if you have something like A plus B plus n, it's the same as n choose k. Yeah, from 0 to n. This is my binomial expansion. I think I told you last time, you came to my office, binomial expansion. Binomial expansion. Yeah, this is the binomial expansion, so that's what I have used. And this step, how is this with this, I can use this also. Do you know the binomial expansion? Alright guys, let me show you how to do question 2 now. So we're done with question 1. Question 2. Right, question 2. Question 2. Part A. So part A is just simply the derivative of these. So what's the derivative of this, guys? You get 1 plus alright, this is the derivative, okay? To find the moment, the nth moment, you get this, which is the integral of xn alright. Now let me ask you, what substitution do you think it will make sense? Where's my pen? It's here. What substitution do you think you should make at this stage here? Huh? I was said y equals to 1 plus yeah, Do you know why I'm doing this? Because this is part of the CDF, guys. If you look at the CDF, this term is the same as this term here. So what are the possible values of this term? The possible values of y? No. Yeah, I know, but it's not 0 to 1. No, it's not right. Come on, guys, think. What is the value of f when x is minus infinity? No, the CDF at minus infinity is 0, right? Okay, it must be 0. So what should this be? It should be 1. So it should be from 1 to 0. So the y should be from 1 to 0, right? Okay. Okay, so let me do you understand why my reason? The value for y should be from 1 to 0, not 0 to 1. Because when x is minus infinity, this is 1. When x is plus infinity, this is 0. So it should be from 1 to 0. So this is what you will get. This will be equal to 1 to 0. X to the power n will become power n, and then you have y um, 1 plus I, and dx is okay. Do you guys follow me? Yeah. Now there is okay. These two cancel out. There's a minus sign here. I'm going to use this minus sign to switch the limits around. Alright, and then I'm going to use the binomial expansion. I'm sure you guys know what the binomial expansion is, right? Don't you? So if you use the binomial expansion, this will be this is what you get. Now the integration of this is easy. If you integrate this, you will get you will get 1 divided by 1 minus k psi. Alright, so that's the answer. So that's the answer to the nth moment. And to find the mean, you just set, this is part C, part set n equal to 1. To find the mean, to find the variance, you just set n equal to 1, and then to All right. Any questions, guys? I mean, it's very similar to question 1. It's just trying to find this correct substitution and then knowing the limits. That's okay? I mean, I'll put this online. There's no need to copy this, and I will scan it and put it online. Yes. Yes, for psi equal to 0, you need to use the because both of these. Yeah, this formula only applies when psi is not equal to 0. And psi, you can't use it when psi is equal to 0. Yeah, should be like that, yeah. Should do it like that, when psi is 0, So for both questions, I think you can only do it when psi is not equal to 0. But for psi equal to 0, this is exponential distribution, and this is the Duffy distribution. So you have to do it a different way. Yeah. That's okay. So next week, guys, we will do case just before you leave. Just before you leave, guys, you have any questions on next week? Just to tell you in advance. Right, next. So far we only done the first 3 cases, case 1, 2, and 3. So next week we will do the remaining 3 cases, right? 4, 5, and 6. Okay. It will be. So we will also do lots of examples next week. Okay. All right, guys. Any questions you guys have? You okay? You guys have any questions? No? What about you? You guys have questions? Yeah. That's what I explained to you. Because this term here, right? Because this is a serial, right? When x is minus infinity, this should be in plus infinity. Yeah, when x is plus infinity, this must be 0. So the limit is always from infinity to 0. You understand? Because this is a serial, and the term, the power term, must, without ignoring the negative sign, the power term must be plus infinity, when it's in the lower end, right? And equal to 0 in the upper end point. Okay? So the limit is always from infinity to 0 because of that. Is that clear or not? Are you sure? Because just look at this term and ask yourself what is the value of this when x is minus infinity. Because remember the CDF is always 0. The CDF is always 0, right? When x is minus infinity. So this term must be plus infinity. Because e to the power minus infinity is 0. So this term must be plus infinity when x is minus infinity. And this term must be 0 when x is plus infinity. Because exponential of 0 is 1.
太忙了，我们这里边客人
Just come and see me. Are you guys okay?
Yeah. If I do, I'll probably do Thank you.
You guys okay? You done good. Okay, thank you. You guys have questions? No, you sure? What about you, sir? Any questions? Oh, okay, thank you. Well, you guys can come and see me tomorrow when you anytime tomorrow. I'll be in my room, so you can come and ask me. Yeah. You okay, man? Yeah. Have a good night, man. We'll see you. If you have any questions, see me in my room. Or Zoom me. You know Zoom, right?
Yeah, that was it.
Yeah. Okay. See you.
Yes,
See you.
么以为你早走了呢？
我没走呢，我他妈走了不就回你了吗？我操，老子你那作业没交。
那能咋的？
我做完我给他交了再走，他妈算分儿的。
算多少分儿？哎呦，还差多少啊？
那家到时候我考了一个，比如说
别逼了，别！
我考了一个69.8，就他妈差这某科的2分。
别逼！
你说到时候他妈是赖你不赖我？
别逼了，别逼了啊！
我不想我去，我屋那傻逼他妈一动就他妈跟踩着的命根子似的，跟叫唤。
什么意思啊？
啊，
什么意思？
那个椅子往一坐，那个咯儿咯儿咯儿在那响。
那你说呀？
我他妈想买个椅子，我问他了，我说我这鸡巴椅子有响儿，他说整个宿舍的鸡巴椅子都有响。
你怎么跟他形容这鸡巴椅子？
我说完全
那也没有鸡巴俩字。
那我他妈能说 my dick hair is so？
我说了得听不明白呀。
我鸡巴这椅子有响。哎呀！真是那个大逼给我发微信，帮人转租校外 W 科。我操，160万个都是美女去去，咋的？转租？我表示我专门租个宿舍就为了养小四，这一下不赚爆了，租一间直接养他妈4个。哎呀！我来哈一句转租 Liberty High Studio， 然后呢全是美女，操，整个楼全是美女。哎呀，这个是我打算去跪下了我的教授，让他帮我保养。
什么？
就这个教授，我打算把它洗干净了，去他的屋子给他保一下。他给我来了一个 unconditional offer， 我操！
什么呀？
考研了，我觉得我不用考研了。